Hello. Tonight I wanted to just kind of go through some progress from the last week since the hackathon on the OpNS overlay and in turn kind of the Go overlay services in general and how that progress is coming along. Um, so what I have here is the actual project for the OpNS overlay. This is in b-open-io is our org that this is hosted under. And it's OpNS Overlay. So essentially the idea here is this is a server that anyone who wants to can run. And we will be running some. I've got one running personally. Gorilla Pool has got one running. So these are essentially overlay nodes. And that is just like a Bitcoin node, but on a much, much smaller network. It just kind of like defers all the finality of everything to Bitcoin. But this is basically node software for a kind of second, it's not really second layer, but an overlay, a little bubble of a network that exists on the chain. And in that, essentially everyone who's taking part in that network broadcasts their transactions dealing with those types of things through one of these nodes. These nodes share the data with each other. They propagate it across the network, and then they propagate that transaction to each other. So essentially, you get in one well-connected node to this kind of secondary mandala thing, the second layer of the mandala, and everything just kind of like propagates amongst those nodes. And there can be any sort of monetary or whatever incentive systems or economic systems or whatever you build around that. But at its basis, like that's what we're dealing with. Overlays are just little nodes that only care about certain transactions. So this process, so I guess in that world, kind of the long-term solution is as people are interacting with whatever tokens exist in this ecosystem, the wallets will know that, okay, I'm dealing with this type of a thing, or the websites will know, or whatever you're interacting with knows that this type of transaction needs to go to this overlay. So in the long term, there shouldn't be any, like we need to hit Jungle Bus and discover what transactions already exist out in the world. But we're not in that place yet. And wallets at this point are still very dumb for the most part. Although we're starting to get, I saw some people do some cool stuff with Metanet wallet at the hackathon last week. The standards are out there. We're starting to get, yours is working toward, I've got a lot of stuff we're working on, but when we get to it, that's going to start using the same interfaces and everything. So we're kind of really embracing kind of the whole BSVA stack and kind of working on the Go versions of these tools. So this system starts with kind of like my system to kind of get the whole overlay bootstrapped. I do have a Jungle Bus subscription, or I shouldn't say a subscription. I'm not actually subscribing. Okay, so OpNS started with one Genesis transaction. And so to get this thing kind of bootstrapped, I looked up in the Jungle Bus spends index, which What's on Chain has one of those as well. And that just basically let me look out, okay, I know what the Genesis transaction is. Let me look up where it was spent. And I got that transaction. For each of those outputs that fit the overlay, let me kind of crawl forward and propagate this whole overlay with what are all the transactions that belong in it. Now, once that's seeded, we'll still probably keep that process around just to kind of to cover the gap until users are all accustomed to broadcasting to overlays. but it's a really, really inefficient process to basically go through every UTXO in the system and just ask Jungle Bus, is this spent? Is this spent? Is this spent? Is this spent? Like that's, and to do it periodically because there's no triggers that says, okay, I can't really subscribe to something that says, okay, when are any of these 5 million UTXOs spent? Like that just, it doesn't work like that. So we need to get people kind of to the point where they broadcast everything into the overlay. Okay, that's enough chitter chatter. So I have got this one stood up right now. This one right here is running at opns.shrugger.cloud. And I'm going to look for who owns the Shrugger OpNS name. And that is me. And this is the out point where I currently own that at. So this is basically going through every transaction that gets broadcasted through it, kind of the rules. I guess I'll go into the tech rules a little bit. So this overlay cares about kind of 3 different types of transactions. Well, I guess kind of 2 different types of transactions. One of them is when OpNS domain names get mined. So that is the contract itself. So this contract started out with this genesis. Every time someone mines a new domain, that contract forks. And so there are, I don't know, several thousand of these UTXOs that exist right now for different names that you can mine off of. But each of those was spent in a chain all the way back to this Genesis transaction. So within our topic manager, so this is kind of the first step of every transaction that gets broadcast through this server, well, that indicates that it's for this topic, we'll go through this process. And this process basically says, okay, for this transaction, what belongs in the overlay? Or does anything belong? Does it interact with this current state of the overlay in any way? And this is kind of standard thing that it's built, kind of standard part of the overlay architecture. So this takes in a transaction in beef format, and it takes in well, this I should probably talk about. In the TypeScript implementation, this takes in an array of inputs which already exist in the system, so in the overlay. So this is basically telling you, okay, this input already exists within the scope of the overlay. I found that I was having to do a lot of database lookups to kind of find out what those inputs were. And so I have actually updated the Go implementation. So rather than just an array of input indexes, it's actually returning a map of input indexes to the beef of that input. So that allows me to kind of parse what was in that input, and the fact that it's in here tells me this is in the overlay. This has already passed all pre-qualifications to belong to this overlay. So essentially, this previous coins is the authoritative state of what we already know about. And this beef that's coming in is kind of here is the proven state that I am contributing to this overlay. And then what we return is admittance instructions, which basically says, okay, what of the outputs of this transaction fit this topic? And then which of the inputs that already existed in the overlay do I want to keep around for state tracking or history or whatever else? And then there's one other thing that I've added here that is different from the TypeScript. And that is this concept of ancillary TXIDs. So the reason behind that we'll get into very shortly, but actually I'll just set that on the back burner. But essentially, this beef that comes in can have a bunch of transactions in it. And as those transactions flow through kind of getting mined, or as the kind of the tip transaction, the one that you're dealing with here, as that one gets mined, well, kind of by normal rules in the beef of that transaction, kind of all the history gets dropped off because we now have a Merkle proof for this transaction. So in order to prove that it was on the blockchain, no more data is needed. But this ancillary TXIDs is saying, hey, there was some transactions in this beef that you need to prove what this thing is, even though those transactions don't fit the criteria of this overlay. These aren't being spent out of the overlay. But in order to tell what this thing is, in order for this topic manager to identify this topic, you got to keep these transactions around. And they were provided when it was first broadcast because the one you're first broadcasting doesn't have a Merkle proof yet. And so all its inputs are being kept around and are broadcast with it with their Merkle proofs. And so this is basically saying, hey, these ones that came in with this, well, when I get mined, don't drop those ones. Those are needed in order to validate what we're doing here. Okay. Let's see here. So I get my transaction out of the beef. And then I loop through all of my previous coins and I make sure the transaction has those populated as source transactions. Let's see here. Then I loop through kind of all the inputs. So in this transaction, what are the inputs from this overlay? Because those are the ones that we actually kind of really need to evaluate the state to figure out if these next ones that we're looking at are valid or not. So for instance, someone else could deploy another OpNS contract and it would look exactly the same if they wanted it to. But the overlay itself is proving provenance. So it is proving, did this go back to this Genesis? And so from just a parsing the script standpoint, I can't tell if this one is valid or not. That's where this previous coins really comes in, is the system's telling you, I've already validated that this one goes back to Genesis. This one you can trust. So basically, I'm going through the things that I can trust to make sure that for whatever they are, this transaction contains the outputs appropriate to fit this overlay and indicates that they should be admitted into the overlay. So kind of we hit for each one of these things. The first thing we're checking is this input, basically, does it parse out as an OpNS mine, a contract? If so, and it already exists in our system, that means if it could get spent, its rules have all been validated. So therefore, the three outputs it spits out, which are 0, 1, and 2, all belong in this overlay. Now, what those will be is kind of that one contract forking itself into two new contracts. The third output is the actual ordinal, the inscription that is your ordinal. So, and then we are going to have the other type of transaction that this process goes through are trying to keep track of spends of the inscribed ordinals that exist in the overlay. So people mine them, that spit out an ordinal. That ordinal is now in this overlay. Every time we transfer this or sell this or list this, those transactions themselves are going to need to get out into the overlay so that we can know who owns a given domain. Okay, so I'm not going to go through the complexity of ordinal parsing. Feel free to take a look at the code, but essentially it's counting up input and output satoshis to find the appropriate output that's tied to that input. And then here is where we use the ancillary TXIDs, because how ordinal transfers work, I need to know how many satoshis are in each input up to the satoshi that's being transferred via ordinal. So if I get a transaction, and in these transactions right here, well, forget these ones. Let's say I transfer an ordinal, and in the transaction, it is in the 40th Satoshi on the output. That's where that gets transferred to me. Well, in order for the indexer to make sense of what that was and to know it's an ordinal in the first place, it has to know, was the 40th Satoshi in already in the system. But unfortunately, I can't know which one is the 40th Satoshi in without having all the inputs that are before that 40th one, because the number of Satoshis in each input is not part of the transaction. It's part of the previous output. So we got to do some complex stuff. But what I basically have to be able to say is, hey, any of these inputs before this one, those you got to keep around, because someone else cannot prove this transaction. You can't prove what happened in this transaction without keeping these previous input transactions as well. So that's essentially the logic for the topic manager. So it's just going through and basically parsing these transactions, and based on if the inputs already exist in the system or not, and if the outputs parse to look like the right thing and follow the right rules, well, then those outputs go in the system. That's the topic manager. The lookup service, I'm not going to go into too much details here. Basically, this is just kind of where you store your own metadata that you want about your thing. So this gets called for every one of the outputs that the topic manager said, yes, admit this into your overlay. Well, each one of those gets passed to each one of these lookup services, which says, hey, this was admitted. Figure out how to store it so that you can do whatever you need to do with it. Basically, this is the lookup. This is the query end. This is where you would build a query engine, or this is where you kind of do very generic lookups into the state of your overlay. And so it has different kind of events that happen as transactions come into the system, as transactions are, I'm inheriting. I've got this Redis event lookup. It's just kind of a very, very basic way for me to be able to kind of from lookup services. In fact, let me just show right here. So here, when I know that this output was added and from the topic, then I can go through, and kind of parse this stuff from a different light. So the first light was, does this belong here? And this light is, okay, yes, it belongs. What do I do with it? How do I categorize it? What's in here? So this is going through, and I've got this very simple event system that's literally just, you come up with a field or a label, and then you have a value. And so you can query things both kind of, you can query the database on essentially on a prefix basis of that string. So you can find all the out points that fit a certain topic. You can find or a certain event, and you can find all the values or all the specific values from an event. And that's just kind of it. Like, it's just this generic search mechanism. And so from a database standpoint, it's just those keys tied to the out point. And then we've got other structures where the out point's stored and everything like that. So I'm using everything with this Redis store, very key value-y. It's a little complex when going through this code, but when using it, you don't know the difference. You're just kind of using the generic lookup interface. Okay. So then this allows me, let me actually go to my database. Okay. So what I've got in here is, let's actually do this by EV. So all of these domains are both stored by where is the current mine location. So this actually got all the historical ones. So for each kind of letter combination, each UTXO in the system, this is where the mines live, and we can search them by what the domain is that has been mined. We can also look up where the inscription itself is. So this is who actually owns this thing right now. Well, technically, this is each of these is who has ever owned these things, but most of them have never been transferred. So most of them are, yeah. I don't even know which one of mine I've transferred. And then also, so that's looking at the out points based on the domain that is in them. The other way is based on who owns them. So this one is me. I own, again, what we're looking at here is actually, these are the out points I have ever owned. Whether they're spent or not is kind of stored in a different place. But this is just kind of, these are the ones that this address has ever owned. Okay, so what all this work to say, okay, from whatever, so this is my own domain. I'm hosting this domain. You can host this on your own domain, whatever. That essentially just means, okay, I can look up who owns these things. So who owns, bet you someone owns Craig. When I say who, obviously I mean what address. That's all I know is what is the out point and who can unlock it, or what, again, not who, what keys can unlock it. That's all we know from this point. Now, there will be more stuff coming to actually tie this into more identity type systems such that you can have kind of attestation that, yes, you own, or you want this name to be used as a representation of this identity. And so you can start tying different worlds together. This is really just a handle system. Okay, so what can we do with all that? Well, so I've also got this set up, and all these right now, I mean, they may work if you hit them, but this is not, these are development level systems right now. Name. Okay. So these two overlays are in sync with each other. So I guess before I go to that magic thing, I have a brand new system right here. Well, I shouldn't say brand new. It's got some services running, but I'm going to go to OpNS Overlay. Yep. Okay. So I just cloned this repo fresh. So now I happen to have these two environments set up the same. So I'm going to, I've already made sure that my env file is sanitized for me to be able to share that here. All right, new file, .env. So it actually only needs a link to JungleBus if you're running that kind of background sync process, and then you need your own JungleBus subscription keys and everything. So pretty much I'm going to be using that to seed the network until we don't need to anymore. But no one else, once this gets up and running, no one else should need to run that piece. Now, if you want to find other ways to discover things that aren't coming into the overlay and get them into the overlay, great. That's awesome. Like, it's just with the JungleBus one, we don't need to be competing on that. Okay, so I've got Redis connections kind of split up into two different pieces. This one is kind of the actual database itself. So like where we keep things like UTXOs, kind of the actual state of the application. Redis Beef is kind of just storage of transactions to beef. So actually how mine is set up, Redis Beef is actually going to KV Rocks, which goes to the file system. KV Rocks is great. It's RocksDB with a Redis interface on it, and it's awesome. So you've got fast SSDs. You can actually kind of use the Redis interface and all the Redis tools to do kind of stuff that isn't limited by the amount of RAM you have. So I have two different database connections. You have to have a block headers URL or a block headers client. You can download that from GitHub. It takes like literally, I think it'll even automatically build a config for you that writes to SQLite on the system where you put it. So it's like, so basically all it does is it spins up, it kind of reaches its fingers out into the Bitcoin peer-to-peer network and processes the block headers. That's all that does. And so you just got to have one of those. You can have one for an organization, there's public ones, whatever. This hosting URL is the domain that I'm listening on. Now, this is actually not the right one for the server, but the server is not going to be public anyway, so it doesn't matter. Okay, so this is the cool thing here. And so overlay services well, we've already built out all the tooling to do this ship syncing, which is kind of like announcing that you want to sync on these overlays on chain, and that's got its own overlay which tracks those things. And so you kind of can look up into a ship overlay and say, hey, who else is running topic managers for this topic? And then you can kind of start building peering relationships that way. I have implemented that in code. I have tested none of that yet. So right now what we have are just kind of hard-coded peers. And so like once that name is out there, for now, that is going to be just kind of publicly open until we get some kind of the next step we're going with a lot of this stuff is going to be starting using the payment middleware and the auth middleware and kind of allowing ways for these different systems to be monetized for what they're doing and also be able to build economics with each other for peering relationships or whatever. But right now, none of that there. So I'm pointing this. I'm actually not going to point it at this one. I'm going to point it at this one because these are on the same network. So it should go much faster. Okay, so in theory, that's all I need to do. Actually, I might need to specify what port I want the server to run on. I do that on the command line. All right. Okay, so I'm running a few different services on this box. Let's just say, okay. We're going to say go run. I'm going to go minus P. I just want to get something that nothing else is using. 8099. That seems safe. Okay. And I'm also going to say minus S equals true. I don't think I need these equals, but I always put them in the go command lines. I don't know why. So that's just telling it sync with your peers. So I will say the syncing right now is pretty clunky. So it has built into it some concepts of being able to kind of do paging, but none of that's really implemented yet. So basically what this is going to do when I start this up, it's going to go out to opns.schroger.cloud, and it's going to say, hey, for this topic, which we've got actually, let me go into that server. So, all right, so we've got this engine thing that you define. And so with the engine, you've got a map of what topic managers you want to run for which topic. So my topic name is this. All right, if I'm going to have it as a variable, I should actually use it as a variable everywhere. Okay, so by kind of in the ship world, TM underscore is a prefix that every topic manager name everywhere is going to have. But these things can pretty much at this point just be claimed. So you start using one and anyone else uses it, well, you're screwing each other's data up, but whatever. You want them to be unique for your topic. I don't yet know if there's any reason why I should avoid the capitalizations. I don't think so. I mean, I think it's just going to be a string that gets passed around, but whatever. Okay. So essentially, I have one topic manager here. It is this OpNS topic manager, which we looked at a bit ago. I have one lookup service, which is this ls underscore OpNS. Again, lookup service is the same as topic managers. They start with ls underscore. So I've got that one defined. I've got my storage. So I've got some different Redis storage adapter things that I've built that allow me to kind of do the databasey stuff. So there's this storage interface and a lookup interface that are kind of defined. And so you just kind of use your own database to do whatever you want to do with those. Change Hacker, this is what is communicating with the block header service and validating block headers whenever I get transactions in. They're validating Merkle proofs, I should say. And then there's sync configuration. So this is kind of where I'm telling it, okay, for this topic manager, these are my peers, which came from that config file. Okay, and this is kind of the important part here. Depending on what your depending on how your different transactions are structured, tells you if kind of how much concurrency you can process your transactions with. And unfortunately, this is an area where at least as they exist and as they're being used, the ordinal type or a token whose state gets transferred from one thing to another. If you start processing transactions highly parallel without doing some extra pre-stop processing to make sure you're not going to step on, because basically if you put a transaction through that depends on certain inputs being in the system, and those inputs will be in the system once that transaction gets processed, but right now they're not in the system yet, well, the overlay is going to reject that transaction. And currently, how this whole system works is once it's made a determination on a transaction, it doesn't do it again. So it would basically say, I've already looked at this transaction. I know it doesn't fit my criteria. Don't keep it. And that fact gets stored. So if that transaction comes in again, it doesn't look at it again. So unless you're going to get a lot of smarts built in before you put it into the topic manager, which you can do, and I have done in BSV 21, but kind of just with the default sync process, you got to set concurrency to 1 with OpNS, or else it'll process things potentially out of order, which will mean things don't get in the overlay, which need to be in the overlay. Loosening up, like I kind of think there's an opportunity to just loosen up that check, and such that if you miss a transaction or you process things out of line, next time you try to sync with a peer, you're going to find out about those same transactions you're missing. You're going to process them again. Now, if things are real scattered, you might end up just making little progress each time, and it's not going to be that efficient either. But again, these are all tweaking things. Right now, it's not smart. Okay. So let's try this up. So I'm going to, first of all, this is that other server. So let's just make my logs nice and big. And let's see if it does it. Okay. Failed to sync with peer. Oh, yeah. Now, 2 problems. First of all, whatever I've got here. Okay, that's not saved. And then this needs to be API/v1. Okay, my server has started up, and okay, it has reached out to get my sync. Okay, and boom, it is now. That's all it took. Was I just needed to point it at some databases, point it at a peer. Obviously, you're gonna have to have a relationship with the peer. Right now, oneset.name is up, but again, it is not production yet. I am probably going to still be messing with this stuff. Things could go down for a while. But if you want to start peering, so the peering as it exists here is kind of, you could be peered one direction, but that doesn't mean that the person is going to be peered back with you. So right now, if you set api.onesat.name/API/v1 as a peer, you're going to get this exact same process. Your system's going to set up, it's going to start peering. Anytime a transaction is submitted to your system, you will forward it on. Although I will say that process is also very untested. So I'm one step at a time here. So your system will push to mine, but I don't know about you. So I'm working on an alternative SSE implementation, which takes the exact same topic events and basically allows you to subscribe to mine, and all it is just giving you an out point, but it's basically telling you, hey, look this out point up from me and process it. So yeah, a lot of this still to come, but why does this all matter? Why would you want to do this? Well, here is where things get cool. So I have in my wallet here a bunch. Some of these domains aren't even valid, but I have all the testing domains from when we first did this 2 years ago. But I think I own some good ones here. Okay, so I own friend, cloud, DCGR, G. I own G. Do I own D? I don't know. That'd be cool. Doesn't look like it. Okay, so I'm gonna go. Okay, so I have very little money in this wallet. I'm going to go to, let's grab another browser window and move this over here. Oops. Sure. No. Well, I guess I can just do it all in one browser. Okay, so this is this original OneSat wallet. So I'm going to switch over to this OneSat main wallet. I have a little more money in that one. I feel like that used to be higher. BSV must be low right now. And BSV is always low. But okay. So this is going to be the biggest test I've ever tried with this before. So I'm going to send. So, okay, let me go back over this one more time. So this is just a server I'm spinning up right now. This is not up to date yet. This one doesn't know anything. This one right here is OpNS.Sugar.Cloud. Now, due to some domain and networking issues and how I have it hosted, I can't actually host a paymail on this server. Just I could do things differently. I don't want to figure that out right now. So how this one is configured, I can't run a paymail server on here, but OneSat.name does have a paymail on it, and I was able to, for testing, point Sugar.Cloud's paymail to that server. So out in the cloud at OneSat.name is a paymail server, and Sugar.Cloud is pointing at that paymail server. That paymail server is running this overlay, and it uses the overlay and it uses this lookup that I did here to actually resolve paymail. So if I want to make a payment to G at, now, let me actually just get one that I'm absolutely sure. Okay, I do own G. So I can say G at OneSat.name. Nope, I'm going to do at Sugar.Cloud, and I'm going to pay 0.1 BSV. And let's see if this works. Okay, transaction successful there. Now, if I go over to this side, I'm going to guess it's going to take a second to get there. Boom, one transaction. Boom, I just got paid. So to recap there, when you run one of these servers, so here's let's do another little test here. So I'm going to go find one of these ordinals. In fact, let me just take the same one of G. Somewhere. G. Okay. Now I will say right now, Paymail is not set up in yours wallet or on this overlay service to do ordinals transfers. There's a different API for that, and I've not figured out how to do that yet. Having said that, I think the regular P2P payment destination endpoint will work if your payment amount is 1. If your Satoshi's amount is 1. And then that's just up on you to construct the transaction right. If my assumptions are right there, we should be able to get yours to support that in the not too distant future. Okay. So this is going to be a little bit painful for right now, but okay, let me go back to my other address. Okay. I'm going to receive. Now we're going to go back to this one, and I am going to now, unfortunately, I want to transfer the ordinal to my other address and show that it changes. But unfortunately, this is where we have one of those wallet things I was talking about, that this wallet right now has no idea about overlays at all. This wallet is just going to transfer the transaction. It's going to broadcast it through the OneSat indexer's broadcast endpoint, which in turn goes to TAL, which then goes on the network. But unless I turn on the piece that's crawling from Jungle Bus, which might have a slight delay, I won't know about this transaction. Okay, so this is where I'm talking about, like, the sync stuff is not real strong yet. But I think we're just going to do this and kind of manually go through the steps that should not be needed in the future. Okay, so we're going to say G transfer. Is that the right one? Yep. Wow, that's taking a little while. Broadcasting. Yay. Okay. So, oops. Let me go to my recent activity here. Okay, so this was the transaction where I just transferred that ordinal. So I'm going to just kind of take the shortcut here. I think, let's see here. I think, how do I add a new key here? Can I not? Well, that stinks. Okay. Z add OpNS score doesn't matter. And member is that. Okay, let's see if this works. So now, now I don't remember where I've got it. It's in process. OpNS, yes. Okay, so my system should now have those, but I think because they were pulled in as historical ones, I think I need to do that on the other system, which just in case, I'm going to move that and do this on another window. Well, actually, yeah, no, because I imported them as historical transactions, it's not going to propagate them. Again, lots of the syncing still need to be solved. But actually, I think that server, sorry, I'm doing hidden stuff now to not leak anything. What do I want? Because I have been known to be careless with what screens I'm showing and sharing. Okay, so I think in theory, if I restart this server, it should reach back out and pull in those two new transactions. Will it do that? It does not look like it. Well, actually, I'm not sure that that logs out. Well, let's see. Who owns G? No. Let me look this up on the other one and make sure it took. Let's go duplicate tab. OpNS.Trugger.cloud. Boom. Okay. This one has been updated. Oh. Oh. This one has not. Oh, it also doesn't look like it might not be configured to sync. Let's see here. Nope, it is configured to sync. Let's try one more restart here. Okay, we got to restart. Oh, yeah, okay, it did reach out. Oh, that transaction transfer didn't work. Okay. So what this means is I have a little more work to do. But you have seen that I am able to resolve a paymail to an address that owns an OpNS domain name. And we got the tools that you can run this yourself and kind of host your own. Now, the thing that's kind of interesting about this, and we will eventually have our servers that you can point your domains at and whatever else, if there's demand for it. But also kind of an important piece of this is this overlay can be distributed. And that's kind of an important piece to all this is there's been a lot of complaints about people getting in projects and getting rugged and whatever. Well, the biggest kind of tip to that is to make the tools such that, I mean, this is Web3. Web3 is not someone else runs something for me. Web3 is, dude, I'm part of the whole. And within the overlays that you care about, like, it takes nothing. This is like the whole of OpNS right now is, let's see if I can figure out how big my database is. So this one right here. Actually, let's go du minus d1 minus H, I think it's much data. KB rocks. Okay, so the full amount of transactions is 1.4 gigabytes. And the actual database itself is 72 megabytes at this point. So nothing. Anyways, so that's where progress is. Next steps. So mining OpNS domain names is like originally people were doing it in TypeScript in a web browser. That code's still out there somewhere. Happy to point you to it if anyone cares to start playing around with it. Otherwise, we're working on kind of getting the payment middleware stood up, and that's another part of the BSVA project is getting that payment middleware working. And once we're going to do that, we will host mining services as well. So you can mine these domain names and we'll do the work and you basically are buying a name. Yeah. Any questions about the overlay services stuff in Go, how to do any of it? I'd love anyone else who's interested in this stuff to actually, like we're going to be doing overlays for Bitcoin social world. We're going to be doing overlays for different aspects of the ordinals world, individual BSV21 tokens, such that if you're a token holder, you actually are validating for the network. Well, assuming you want to, assuming a token has enough support, people can just run that token. And that would even, well, I don't want to say that. There's problems with things like first is first rules. So OJBK could exist as its own overlay, but the problem with that is you don't really have proofs that what came first came first. Now with OJBK, does that matter? There's more supply than anyone will ever mine, and it's free. So you could have an OJBK overlay if you wanted. You could do whatever. And so we're going to start kind of moving things more and more to that kind of in that direction. And along with that means if you want to run a token marketplace, you can actually run the marketplace overlay and share liquidity with other people who are running those market overlays. There's also some really cool things with various kind of Web3 liquidity providing things that kind of these overlays allow you to do things that kind of take the current world of how we do things in blockchain and flips it on its head completely. And it's really awesome. Lots of cool stuff. So anyways, this is just the beginning and we're still working and we're going to be plugging together more and more of the BSVA stack in here. Again, we can have authentication and payment, and it all uses Bitcoin wallets to kind of do all that stuff. So things are going along great. And that's it for tonight. Thank you, everyone. Good night.